Okay, these notes are for integrated 1, it's for 8.1.5. We're going to talk about how we can start with a graph and try to write the equation for it. So make sure that you follow along with this video, and as we go through each of the problems, make sure that you are recording this in your notes for our class. Okay, let's take a look at question number 20. So the first thing that I want to do on any of these is check to make sure that I have a general idea of what this equation is. So if I take a look at question 20, that looks pretty familiar. It looks just like the stuff we've been doing recently. So the first thing that I would say about question number 20 is this does look exponential. Additionally, since it starts low on the left and goes up towards the right, I'm going to make a little note to myself that this is exponential growth. Okay, so keeping that in mind, I know that the equation for this is going to be a times b to the x. So just like what we've been doing, where a is the zeroth term and b is the multiplier. Okay, so I'm going to take a look at the graph, and really what I'm going to do is I'm going to fall back on what I already know, which is the idea of making a table. So I need to figure out what these points are. So the first thing, I see this point where I've got a 5. So I'm going to go ahead and color code that green. Since it is the y-intercept, I know this point is 0, 5. Okay, now, if we take a look at this movement here, remember it's the x-axis that goes right and left. So if I take, I'm going down to the x-axis, so where I'm at, if I'm at 0, so in orange, looks like I'm going +1, so 1 to the right. So I think that's 1. Then I need to figure out how far I'm going up total to get to that point. Well, I know, so going back to my green, I know that the vertical height to get to the green point was 5 units. So I know that this distance is 5 units. But then I've got this +2. So it looks like I'm going up 2 units further. So I would say that this is actually it's 7 because it's 5 plus 2. All right, now the orange point. So if I take a look at it, I went 1 over on the x-axis and up 7. All right, so now what I'm going to do is I'm actually going to take those guys and put them in a little table here. So underneath this guy, I've got an x and a y. I have 0, 5, so the green point, and then 1, 7. I don't have any other points, but because I know that this is exponential growth, I know that I can actually write an equation for this. So I know that 5 times something, let's call it b, has to give me 7. So I'm going to do 5 times b is equal to 7. I'm going to divide by 5. So I'm going to divide those 5s out. So at this point, I'm going to go ahead in my calculator. So make sure you have your device pulled up. We're going to do 7 divided by 5. That's going to give me 1.4. Okay, I've got my multiplier. So there's b. Looking back at my table, do I know what a is? Well, remember, a is the 0th term, and I think we know what it is because we were given the point 0, 5. So I think we're being told that a is equal to 5. Now that we have all of the pieces we need, we can go ahead and write the equation. So remember, this is y is equal to the exponential equation that we've been using. Plug in our a that we just found, or was actually given to us, 5, and then the b that we calculated, 1.4 to the x. I believe this is going to be our answer for this question. So we just wrote the equation for question number 20. Okay, same process on 21. I'm going to do the exact same thing. So I'm going to take a look at the graph. I see that this point 4D is right on top of the y-axis. This is good. So this point is 0, 40. Now, what's really nice about this, my orange point, it's just another point. I basically just need 2 points. We know how to find the 0th term if it's not given to us. We just need 2 points, and then we'll write an equation to find b. Okay, so this one, that's already given to me. So there's my -1, 120. So I'm going to go ahead and put this in a table. Now, looking at the graph, it looks exponential to me. It's got that same general shape, except here, it's not exponential growth. It's actually exponential decay. But that'll work itself out in the equation anyway. So we're still going to do a times b to the x. All right, here we go. So let's make our table here. And remember, I want to do the point on the left first, so smallest point first, which was -1. Take a look at the x value, 120. And then the next one, which was 0, 40. Now my process is going to be the exact same thing. I know, so again, make sure that the first x, so the first point that you put in is the point that's furthest to the left on your graph. And then the second point is the one that's furthest to the right on your graph. All right, so now, since this is exponential, I know that's going to be times some value b. So let's do 120 times b is equal to 40. All right, let's divide by 120. Divide by 120. B is equal to, when I type this in my calculator, I get 0.333 repeating over and over and over again. Okay, so I've got my B. All right, now looking back, do I know what my A value is? Yeah, I do. It was given to me again. It's right there. It's my y-intercept. So this is telling me that A is equal to 40. All right, let's go ahead and start writing this equation. So we know it's exponential. So y is equal to a b to the x. Let's plug everything in. So a is 40. The b that we got was 0.333 approximately to the x power. That is our equation for this one. Now, important to note, we've got some really nice things that happened on both of these. So I'm going to keep looking at the second one, or the 21 that I'm looking at. If you take a look, notice that the x's are one right after the other. So on a number line, -1 and then 0 are only 1 unit apart. So I didn't skip any terms. Back on 20, we have the same issue from 0 to 1. That's 1 unit. They'd be one right after another. It's going to change if they're not like that all the time. Okay, let's take a look at question number 22. Okay, so looking at the shape of the graph, this is not exponential. This is going to be linear. And I think it's kind of hard to see based off of the fact that the lines look like they're lining up completely. Okay, so this guy in orange, that's the actual line that we're looking at, the actual graph. This is not exponential, so I'm going to say that this is linear. Additionally, I am going to say this is a horizontal line completely, which means with a horizontal line, all I'm going to do, my basic equation is y equals some number. And it's whatever the y value is at any of the points on the line. So if I take a look here, I'm given one of the points, 5, 18. All I care about is the y value here, which means the equation for this one, I don't have to do a lot of work, a lot of thought, very little work, is y equals 18. Shouldn't be too bad because we have been doing horizontal asymptotes, and horizontal asymptotes are horizontal lines, which are always y equals some number. Okay, question number 23. This will be the last one for our notes. Take a look at the shape. This looks exponential to me. So I'll say that this is exponential. And then I am going to say this is exponential growth. So y equals ab to the x. And I'm going to do the exact same thing that I did. Oh, I don't even have to figure out what the points are. I know what the points are. Okay, I'm going to make a table. I want the point furthest to the left in the table first, which looks like it's 0, 7. And then the next one doesn't occur until 3. So I've got some gaps I need to fill in here. So at my table, I didn't have anything for 1. I didn't have anything for 2. I'm going to leave them blank. I do have something for 3. So at 3, I'm at 56. I know we did a problem like this a little while ago. The idea is still exponential, which means it's still repeated multiplication. I propose we make an equation. So we know 7 times b gets us the y value when x equals 1. But we don't have anything there, so I'm going to keep going. I have to times by b again. I haven't gotten there yet. Times by b again. Okay. It looks like I have to do 7 times 3 b's to get 56. All right, well, remember that exponents are shortcuts for repeated multiplication. So I've got a whole bunch of b's multiplied together, and I'm going to take a look at how many. So I've got 1, 2, 3. So that means I have an exponent of 3. Bring the 7 down, bring down the 56. I'm going to divide by 7. Divide by 7, those cancel. I'll get b to the 3rd. Well, type that in my calculator and I get 8. So now, just like we did with square roots, we're just going to look at the exponent. Exponent is a 3. So we're going to do on both sides is we're going to put a root, but we're going to put a 3 in the crease because we need the red 3 and the blue 3 to match so they cancel. So the red 3. On the left-hand side, those cancel. So we get b equals. Basically, what the right-hand side here says is there is some number so that when you multiply 3 of them together, we get 8. Now, you do have a button like this in your scientific calculator. So in the scientific calculator, it's in the bottom left, and it looks like, so here, I'll draw it off to the side for you. It looks like a root symbol, but it has an N there. So you're going to want to select that button. Make sure that you put a cursor over that N. It should be a blank location. You're going to type a 3 in there, and then inside, you're going to type in an 8. So just like we have it written down here. When you do that, you will get 2. So we know our multiplier. Okay, looking back, do we know the 0th term? Yes, we do. This is nice. It's right there. Now, if we didn't know it, remember, once we have stuff set up in our table, we can always divide to go backwards or multiply to go forwards, however many times we need to. All right, let's write our equation. So we get y equals a was 7 times the b that we found to the power of x. Now, use this video to help you work on today's assignment. Remember that tonight's assignment is due by 11:59 p.m. this evening.